Hello, welcome to my channel. Today, class 11th, I will give you some facts and interesting information regarding a measuring device called screw gauge. You know, it can measure up to 3 places of decimal in centimeter. So, a very fine measurement is taken by this device, and what are the you will use this device and about the total description, how to measure the diameter or length up to 3 places of decimal, I will describe it fully in today's video. Before proceeding further, I would like to say please subscribe my channel and press the bell icon for further notifications. Look, this is the screw gauge, and what is written here at this part, is it visible? Look, this is written 25 into 1 upon 100. So first thing is that 25 means the distance from this gap from fixed end to this one is 25 millimeter. Second thing, 1 upon 100, it is its least count. This screw gauge has 2 scales. Look, I am rotating the screw. This is the fixed end and this end is rotated, and you get the gap here, it is opened. So if you look here, that this is the main scale. Is it visible? There is a base line, 0, then 5 will be written, and in between 0 and 5, how many divisions are there? Is it visible? Count. Is it 5 or not? Look, is it? So there are divisions on the main scale, and along the base line they are equal divisions, and before and above the baseline 0, then 5, then 10, so many numbers are written. This is the main scale, and here each division is of 1 millimeter. Look, the circular scale I am showing here, I am rotating the circular scale. You will see that 0 will come in front of you, then after 0 what number written will be there? 10, and in between 0 and 10 there are 10 divisions. So 10 small divisions in between 0 and 10, and total number of division you count 10, 20, 30, 40, 50, 60, 70, 80, 90, then after 90 10 more divisions. How many total divisions? 100. Sometimes it is asked that how many divisions are in circular scale, then you find that 90 is written, 100 is not written anywhere. Then most of the students say that 90. No, after 90, 10 more divisions to reach 0. So how many total divisions on circular scale? 100. Now this is the screw which is rotated. So look, one more thing, that is called pitch. So look, what do you mean by pitch? That if you adjust 0 in front of the baseline, coinciding the baseline 0 of the main scale, suppose you put the 0, and let me see first that suppose this is the 0, and how many divisions or main scale are open. So suppose this is 0 and total divisions open are 10. Look, I think this is visible that 10 divisions on main scale are open, and 0 is of circular scale coinciding the main scale. Is it or not? Then if I give full one rotation, complete one rotation, then you bring 0 again at that place. Is it? Now look, how many divisions are there? What is the reading of main scale now? Is it? Look, how will you read? How many divisions are open now? 9. Let me see. I have, yes. So in this way, if after one complete rotation you have seen that this circular scale covers one division on main scale. So it means that circular scale covers some linear distance on the main scale, which is 1 millimeter, because one division is covered by screw in one complete rotation. The circular scale covers one division on rotating it by one complete rotation. This is the pitch. So make it clear again that if suppose I open the 5 divisions and this is 0 coinciding with 5. Look, is it visible that 0 of the main scale is in coincidence with the 5 written at the main scale, 0 of circular scale? Is it visible? Then if I rotate the screw in this way, now again the 0 will come at its own place. It has come. Let me see, it has come. Then how many divisions are open? I have rotated in opposite direction. Then look, now the reading is 5.1. Is it clear? So if this circular scale is rotated in this direction, then one division is covered by it, and if it is rotated in opposite direction, how much? One complete rotation, then one division is opened. What does it mean that circular scale covers one division on rotating it on circular main scale? So the pitch is that distance which is covered by the circular scale when it is rotated on main scale. And what is that distance here? 1 millimeter. So what is pitch? 1 millimeter. So look here, I will tell you about screw gauge. What have we read till now? That there are two scales, main scale and circular scale. Here number of divisions on circular scale. On circular scale I will write CS, they are 100, and main scale value of one division equal to 1 millimeter. Remember, another type of screw gauge is also remain present in the lab, in which the value of one division on main scale is 0.5 and number of circular scale division are 50. Now least count of screw gauge is given by pitch upon number of circular scale division. What is pitch? Just now we have seen 1 mm upon number of circular scale division 100. So its least count is 0.01 mm or 0.001 centimeter. Second thing is zero error. In the screw gauge, what is done that this open end, this fixed end, and this is movable. When movable end is made to touch with the fixed end like this, and with one sound like this, you will find that if 0 of the main scale and 0 of the circular scale, they are not coinciding, then there is a zero error. Look here, what are you observing? They are not coinciding. So zero error is of, you will find what do you mean by zero error. If zero of main scale does not coincide with zero of circular scale, only then zero error is there, it occurs. And if suppose this is the main line and this is the circular scale, here the zero of main line and here the zero of circular scale, both are in coincidence, then zero error is nil. There are so many divisions on circular scale. But if the circular scale like this, its divisions are made, and this is the zero of main scale, this is main scale and this is circular scale, this is main scale and this is circular scale. What do you find? That if zero of circular scale lies above the main scale 0, when both the ends are made to touch, then suppose here it is, this is 0 here, then what will be reading before 0? This will be 99, this will be 98, this will be 97, suppose this is 96. Okay, so what do you observe? That before 0, here it will be written somewhat, this is 95, 4, 3, 2, 1, so this is suppose 90. So if 96th division is in coincidence with the 0 of main scale, then this is called negative zero error. So how will you observe negative zero error? When on touching both the ends of the screw, that is movable end, it made to contact with the fixed end, what we observe, that 0 of circular scale lies above the main scale 0. Then we read the coinciding division, that is 96. Then this 0, if it is above the main scale 0, then this is negative zero error. How will you read? Then you read the coinciding division, it is subtracted from total number of division. How many total number of division on circular scale? 100. So it is counted as total number of divisions on circular scale minus coinciding division into least count. So what is here? 100 minus 96, and you will put here with minus sign. This is minus sign into least count 0.01 mm, and this is minus 0.04 mm. So in this way, this is the negative zero error. Another zero error, what do you observe? That if the 0 of main scale, suppose here it is 0 and this is the circular scale, then what we observe, that if 0 of circular scale lies below the 0 of main scale, suppose it is here, it is written 0, then 1, 2, 3, 4, 5. So if the fifth division is coinciding with the 0 of main scale, then this is called positive zero error. Again, how will you observe which type of error is that? You will, this fixed end, you will make movable and bring closer, screw is brought closer and touched with the stud. Stud is the fixed end. Then it is observed that what is the position of zeros. Then if the 0 of circular scale lies below the main scale 0, then positive 0 error. Directly you read, then what number is in coincidence with the 0? It is 5. Fifth division. Which division is in coincidence? Fifth. You will count. Then directly coinciding division into least count is the amount of 0 error. Coinciding division into least count, how will you write? What is coinciding division? 5. Then 5 into 0.01 mm. What is that? Plus 0.05. You will write here 5 into 0.1, 0.05 mm. So positive 0 error is this, negative 0 error is this. In this way we calculate the error. After finding least count, pitch and 0 error, how will you calculate the measurement? How will you take the observations? You find the table here, main scale reading, then circular scale reading, a big column. It has two parts, coinciding division and coinciding division into least count, then total observation, then corrected. Then which two observations are summed? Suppose this is A, this is B, this is C. In total you will add A plus C and corrected. How will you correct the 0 error? First of all, when you are given a screw gauge, you see which type of 0 error, how many divisions on circular scale, main scale, then pitch, 0 error you have to see. Suppose this is the screw gauge in which, look, there are, when I have touched this, what is the coinciding division of circular scale with the main scale? Look, it is 93, 94. What is there? What is coinciding division with the main baseline of the 0 line of the main scale? So let me see. It is, this is, yes, it is 92. So if it is 92, look, then, and 0, where is 0? 0 is above the baseline. Which type of 0 error? It is negative. Is it clear? So look here, 0 is above the baseline. Here I have given the example 96 was the coinciding division. In this screw gauge, what is the error? So 0 error is 100 minus 92. What is that? 92. 100 minus 92 is 0.08. So 0 error you have written here in the observation. You will write here that negative 0 error and minus 0.08 mm. Now you take the observation. Suppose you want to measure the diameter of this rod. Then what will you do? You fix the rod in between the space, the fixed stud, and you make the screw so that this rod can be made tight like this. Now what will you take? How will you take the observation? Look here, that main scale reading. You look, what is main scale reading? How many divisions on the main scale? It is 10. So you will note down main scale reading is 10 mm. Then which division of the circular scale coinciding the main scale? Then it is here 86. Look, is it? Look, is it after 80? Which division is coinciding the baseline? Is it 86? So in this way you have to see coinciding division. Then you will write here this 86. Now 86 into least count. So 86 into 0.01. What it will become? 0.86 mm. Then what will be the addition of 10 and millimeter and 0.86, it will be 10.86 mm. And very important thing, corrected reading. Then how will you find 10.86 and this zero error? What will you do? Note down, zero error is always subtracted with sign. So from this, if you will subtract this, and this is already negative, then this will be added. So what will happen here? 10.86 minus 0.08. So it will become, this is 0.616. It will be added, so it will become 4, this is 9, and this is 10. So it will become 10.94 mm. So the exact, in one observation, the diameter of this rod is 10.94 mm. Now you have read in error analysis that if number of observations are more, then chances of error, they become less. So it is the rod of uniform thickness. You again take second observation, you take and hold the rod in this way at some other place, then take observation, and 5 or 6 observation, take mean, and you will find the exact result. I hope you must have understood how to use screw gauge and how to take observation. Thank you.